Welcome everyone, and thanks for attending our online webinar. Before we begin, I'd like to acknowledge the traditional owners of the land throughout Australia and pay respect to their elders past, present and future. My name's Rebecca and I'm from the Naval Shipbuilding College. Today we're going to take some time to find out a bit more about career opportunities that exist in Australia's naval shipbuilding industry, and we're going to talk to one of our experts in the industry, Sprudo. We'll have some time at the end of our presentation for any questions that you might have about anything that we're going to talk about today. So a little bit about me. I'm an aeronautical engineer and I have worked in a range of different industries, including defence and civilian. But as you can see, I'm currently working in shipbuilding, and it just shows how transferability of skill across multiple industries can just take you anywhere. So well worth looking at your career and a pathway in naval shipbuilding. One of the most common questions is, what is naval shipbuilding and why do we have a naval shipbuilding industry? Australia is surrounded by ocean, so this means that we need our Royal Australian Navy to be as modern and effective as possible to keep us all safe. To have our Navy the best it can be, we need to design, build our own ships and submarines so that we're not reliant on getting these from any other country. That's why Australia has a naval shipbuilding industry, to design, build and maintain all of our ships, submarines and other vessels required for the Navy. This means we're not reliant on any other country other than our own, and we're completely self-sufficient. These vessels are not only used for nation security, but for humanitarian, peacekeeping and disaster reliefs. Now that I've said naval shipbuilding, you're probably thinking of working with big sheet metal, big sheds, and that's some of the work that's done, but modern shipbuilding is highly technical and incorporates cutting-edge engineering, technology and systems to ensure that the ships and submarines are invisible to attack, can detect threats and ensure the safety of the crew on board. This industry is one of the most technologically advanced in the world. It's just as advanced as sending something into space, except we're sending submarines to the bottom of the ocean. On to some exciting stuff. What are we building in Australia? Essentially, we're building a few different types of ships and submarines. More than 70 vessels will be handed over to the Navy by 2050. As you can see on the slide we've got here, we've got various classes of frigates. So there's 9 Hunter-class frigates which are being built in South Australia. These are submarine hunting surface ships, and they're designed to be super quiet and stay invisible to threats. These have some of the most advanced sonar and radar systems on board. There's 12 attack-class submarines being built in South Australia. Heading under the water, these are some of the most advanced submarines in the world. There's 12 Arafura-class offshore patrol vessels which are being built in Western Australia. There's 21 Pacific patrol boats being built in Western Australia and 6 Cape-class patrol boats in Western Australia. Most of the work, as you can see, is happening around South Australia and Western Australia, but there is work right across the country, and there will be for the next 30 years. The builds of the Hunter class and Attack class will run through until 2050. This means you have the opportunity for a stable and long-term career, no matter where you are in Australia. So that's what we're building, but there's also sustainment, which happens right around the country. If you think about these vessels and submarines like a car, they all need to be maintained. They have regular services and upgrades to ensure that they have the most up-to-date systems and technologies on board. One of the key things about the shipbuilding industry is it's big and it's long-term. The Commonwealth Government is committed to spending over $180 billion over the next 30 years, which will result in more than 15,000 positions required in the naval shipbuilding industry. Here you can see the sheer scale of the Attack-class submarine and the Hunter-class frigate and how big they are in comparison with other objects. So you can see on the slide the Hunter-class frigate is the size of a football field, which is pretty big. And when you think about the type of sheds that need to be built to house these sorts of vessels to maintain our builds over the next 30 years, there's a lot of infrastructure and a lot of jobs to be available in Australia. So a fun fact for you about these builds is that the last sub will be built in 30 years' time, which means the captain of that final submarine is probably not even in primary school yet. The tradespeople and the junior engineers who work on that last sub, they probably haven't even been born yet. That's how long this industry is in Australia and how much longevity there is for your career. So you've heard about the size of what we're building. It is big, so that means it takes a long time and there's a lot of components. The car you drive around takes less than 1 day, 23 hours to build, and it is made up of around 3,000 parts. The plane you take on your family holiday is around 50,000 hours and it has around 100,000 parts. In comparison, an attack-class submarine will take about 8 million hours to build and about 1 million parts, and we're building 12 of these submarines. If you convert the hours into days, that's about 333,000 days of work on a signalled submarine. That's impossible for one person, which is why we need thousands of people in all different types of roles to work on this project. If you think about the parts, they all have to come from different suppliers in the industry and the supply chain, which makes up thousands of companies across the country. And without rigorous inspection, adherence to stringent specifications, the attack class would fail in its mission to keep our seas safe. So there is a whole lot of jobs available and a different range of jobs for everybody. I'm going to hand you over now to our expert on sonar, Sabruto. Over to you.
Thank you, Rebecca. Good evening, everyone. My name is Subroto, and I'm ex-Navy engineer working in Naval Shipbuilding College at present as a training solutions manager. So today I'm going to present on some scientific facts about dolphins. Then we'll draw a comparison of the dolphins with the submarines and ships. Now, the common thing in both the cases is equipment called sonar. So sonar is an equipment which is used for underwater detection of objects. Sonar stands for sound navigation and ranging. So it helps in navigation of the ships. It also helps in finding the distance of object from the ships. In my past life overseas, I was working in the Navy. My primary role was electrical engineering, and part of my role was to maintain the sonar on board the warship. My secondary role was as a ship's diver, and as a ship diver, I used to go underwater and check the dome of the sonar. Now this sonar is sitting under the ship and it is projecting into the water. So the sea water is highly corrosive, and if it is exposed to the sea water, the electronics in the sonar will be not working. So to protect that, there is a dome which covers the sonar electronics. While in the Navy, I also happened to work in a defense lab, and my role was as a research scientist. So I was doing the analysis of sonar signals for the detection and classification of underwater targets. So on the right, you can see there is a badge which is known as Dolphins badge. And this is showing a couple of dolphins which are kissing. So this is a badge earned by the submariners when they fully qualify to work on board the boats or the submarines. Now I'm going to play a video of a dolphin sound. Listen to that video carefully and then we'll talk about it. So Jason, can you please play the video? Okay, so you heard those clicking and whistling sounds of the dolphin. So those are the usual sounds dolphins make to communicate with their family members or their friends. Besides communicating with their own species, they also use this sound to detect prey or to remain away from the predators. Now in this picture, there is a dolphin which is making sound, and those sounds are going in the form of sound waves. You can see those arc-like things. And at a far distance, there is an object lying on the seabed. So this is a can which is lying on the seabed. Dolphins have got very good eyesight. But what happens if the object is at a very far distance? They can't see the object very clearly. So what they do is they emit this sound these sounds get reflected from that object. In this case, it is a can. They process the sound which is reflected back, and they can make out what type of object it has come back. Now they are so smart, not only can they detect the can, but they can also detect what is inside the can. In one of the experiments, it was found that dolphins could distinguish between a seawater, freshwater, and even oil. So that is the amazing capability of the dolphins. Now let's see how these dolphins are able to detect object using sound. So in this picture, I will focus on the head of the dolphin. And this is the zoom part of the internal part of the dolphin. So this is the nasal passage. All this clicking and whistling sound, they are transmitted through this nasal passage. It goes through this fatty tissue known as the melon. This fatty tissue, what they do is direct the sound into a particular direction. So these arrow-like things are showing the sound is traveling outwards. If there is an object in front of that sound, it will get reflected, and these arcs are showing the reflected echo which is coming back. This echo is collected through the jaws of the dolphin, and they process it to find out what type of object it has reflected from. Now, since it is processing the echoes from the object to locate the object, it is also known as echolocation. This phenomena is occurring in the dolphins, so we call it as a biosonar or biological sonar. So you see they can see things even if they are blindfolded through their hearing mechanism. Now in this picture, there are 3 bottlenose dolphins. As I said, they are very good in seeing objects, but in case of this picture where they are operating in a murky water, they can't see much. So what they do is they use those sound to hear and locate the object. Now I'm going to go over to the sonar, which is fitted on board ships and submarine. So I'm going to play a video of the sonar. So listen to the sound, then we'll talk about it a little later. Okay, so those were the sound emitted by a sonar fitted in a submarine. So those transmitted sound are known as pings in the jargon of submariners. So if you look at the picture, this bright light, which is like a torch light, is indicating that the sound is being transmitted from the sonar. And in case there is an object in front of that sound, it will be reflected back and it will appear like a dot here. So this dot is indicating that there is an object in this direction, and it can also give the distance of the object from the submarine. Now we'll talk about how the sonar works. So there are broadly 2 types of sonar, active and the passive. In the active sonar, the sonar will transmit a sound, it gets reflected from an object, and it will process the reflected sound. Whereas in the passive sonar, there is no active transmission. All they do is listen to the sound which is underwater. They capture those sonar sound, and then they do a processing to find out what is the object. So coming back to this picture, we have active sonar system, which is fitted on this warship. As I said, the sonar is located at the bottom of the ship. This blue color is indicating the portion of the ship which is underwater. So the sonar here will transmit the sound, which is known as the source level. So at this point, the strength of the sound is very high. As it travels through this seawater, there's going to be some losses, and we call them as transmission loss. And you can see there's a submarine passing beneath the ship. If this sound touches the submarine, it will get reflected back, again go through the seawater, some transmission loss, and finally the signal that is collected by the sonar is known as the echo level, which is a weakened signal, and this signal is processed by the sonar to find out what type of object has deflected that sound. Besides finding the object, they can also find the distance of the object, in this case the submarine. So what they do is they calculate the elapsed time between the transmitted sound from here and the received echo. So that time will give an indication of the distance of the object. Now this is a picture of a submarine which is raised outside the water, and you can see the shape of the submarine looks quite similar to the dolphin. And you can see there are a lot of people standing in front of the submarine. So you can imagine the size of the submarine compared to the human being. This is a French submarine, and it has got a name called the Terrible. Now we're talking about some of the applications of the dolphin. So US Navy has got some dolphins which are trained to detect mines underwater. So what are mines? Mines are underwater explosives. If you look at this picture, there is a camera fitted on one of the fins of the dolphin. So this camera will go and show the location of the mines to the people who are on the surface. This is one incident which happened way back on 8th of March 2014, where the Malaysian Airlines Flight 370 disappeared above the Indian Ocean. It is believed that the aircraft crashed into the Indian Ocean and it was never found. So any aircraft which is flying over the seas are fitted with a device known as solar locator beacon. So this device gets activated as soon as the aircraft hits the sea. So it is a salt water which is going to activate the battery, and then that device will keep on emitting beacons. So they are nothing but sound. So these beacons can be collected or received by any sonar fitted on ships and submarine, and they can home on to the site of the crash. But these batteries have a shelf life, and they also have an operational life. So if they're activated, they would last around 72 hours. So the ships have to be quick to locate the crashed aircraft within those hours. Now this is another picture. If you look at this battery-like thing, this is a small sonar which is used to scan the bottom of a river. One of the car, it went into the river and it was sitting on the bed. So this rectangular piece of image, if you can see, this is indicating the location of that car. So this can help in detection of car which is submerged in the water. Couple of weeks back, I was reading a news about this Thursday Island. This island is connected to the Horn Island for their freshwater supply. So there is a pipeline which is running between the two islands, and this pipeline is the only source of freshwater. What the local authorities found was the supply of water was not enough. So they suspected there's some leak in the pipeline. Now this pipeline is sitting under the sea and also buried in the sand below. So they were worried how to detect this leak. Fortunately for them, there was one survey vessel passing nearby. So these survey vessels are known as hydrographic survey vessels, and their role is to scan the bottom of the sea near the coast, and they make maps and chart of the coast. And those maps help in the navigation of the ships near to the coast. So they came to their rescue, they scanned the bottom, and in this circular red patch, you can see they found some the sand was lifted up. So if you look at the zoomed portion, so this is what they found through their sonar. So this was a suspected area. One of the divers was sent to the bottom of the river or the sea, and the diver found a hole in this pipeline. He plugged it, and the full supply of the water was restored. So if you have got excited with the dolphins and their sonar capability and think that you would like to do some research or work on this area, there are few roles in the naval shipbuilding industry. In the entry level, you can work as an electronics engineer or technician. After a few years of experience, you can work as a combat system engineer or technician. And if you are very keen to go further deep into the study, you can do a PhD and work as a signature engineer. With this, I will hand back to Rebecca. Thank you.
Thanks, Bruto. That was a fascinating insight into how dolphins use their sonar and how we've picked up that technology. So thanks very much. Remember, you'll have an opportunity to have lots of question and answers in just a couple of minutes. So if you want to ask a question, please click on the blue hand icon and just type in all your questions there, and we'll ask those questions very shortly. Before we get to that though, I'd just like to tell you a little bit more about the jobs in Australia's naval shipbuilding industry. As Bruto briefly mentioned at the end of his presentation, there is a range of jobs available specifically for some of his sonar work, but we will need at least 15,000 people to work on these projects over the next 30 years. So there are a number of different companies and employers and lots of different roles for you to have a look at and to get into the naval shipbuilding industry. Across the enterprise, there'll be an opportunity to work for the primes. These are the large companies who hold the contracts for the design and build of the vessels that we talked about earlier, like BAE Systems Australia, ASC, Naval Group, Austal, and Lursen. There's also opportunities to work for a small to medium enterprise, or SME, who have been awarded contracts by the primes to design and supply parts and components that will be required, from the nuts and bolts that hold the ships together through to complete engines and software systems. In terms of location, we talked about that a lot of the builds will actually happen in South Australia and Western Australia, but there are other roles that will be located all around Australia. Having said that, we are currently seeing, and we will continue to see, lots of roles advertised around most states and territories. A key thing to note here is that you don't need to enlist in the Navy to work in naval shipbuilding. In this industry, it just happens that the customer is the Navy, so you don't have to become a sailor. It's just a job like any other business. So what types of jobs do we have? There will be job opportunities across 5 job families being engineering, trades or operations, supply chain support, and project management. Some of the most in-demand roles are with engineering and the trade families. So let's look at those a little bit more closely. In naval shipbuilding, there's going to be huge demand in the coming years for engineers specialising in software, mechanical, electrical, electronic, naval architects, systems engineers, and combat systems engineering. In the trades, there are 3 areas highlighted for the most demand, and these are heavy fabrication, mechanical tradespeople, and electrical tradespeople. Demand for trades will accelerate heavily from about 2024 to 2028 as we start to get a lot more of the vessels being built simultaneously. Some of the job roles that sit inside these trades, like heavy and light fabrication, are boilermakers, welders, sheet metal workers, and pipe fitters. In the mechanical trades, we've got machinists, mechanical fitters, we've got electrical tradespeople, such as electricians. So how can NSC help? I'd like to talk to you a bit more about NSC. So NSC is an Australian government initiative, and we're here to help you get into naval shipbuilding as a career. We're a free service to help you plan your pathway into the industry and then connect you with the job when you're ready. We work closely with the shipbuilding companies to understand what jobs they need to be filled and when. We also work with TAFEs and universities across the country to ensure that you're studying courses that will teach you the things you need to know to get ahead for your career in naval shipbuilding. So as you've heard, there are many different pathways you can take to whatever it is that you want to do. You might already have a clear picture of what you want to do after school, or maybe you're stuck and really don't know which career is for you, but that's okay. We can actually help turn your interests into a career through our workforce register. What this means is we'll set up a free chat with one of our team and they'll speak with you about what you're interested in, your favourite subjects, your hobbies, what you'd like to do for a career, and then maybe give you some advice on some things like the jobs you might be suited to, some subject choices you might need at school. And based on this information, we can chat and the chat that will provide some pathways and options and referrals into different courses. We can then keep in touch throughout the journey, and when you're fully qualified, you'll gain access to our jobs portal, which connects you through to employment opportunities across the enterprise. Students of any year level can join the register via our website or Google Naval Shipbuilding College and select the button that says Join the Workforce Register. The next screen does look a bit scary, but it's not. Just enter your personal details like your name and phone number and then hit submit. You can ignore all the parts where it asks for your resume. We don't need that just yet. We'd like to just get some more information from you first. In the coming next few days, you'll get an email with a few times to choose from to set up your chat. You can pick a time that works for you, and you're welcome to have your teacher or parent sit in on the chat with you as well. It's that easy. So hopefully you've learned a little bit about Naval Shipbuilding College and how we can help you get into your career started. We'll move into some questions now. So if you do have any questions, please just click on that blue icon and then we'll run through some of them. Feel free to ask a question of Sabruto if you'd like to know anything about the technical aspects of sonar. And of course you can ask some questions for me as well. So I've got a question here about what security clearances do you need to work in naval shipbuilding. So different companies have different requirements, and of course different job roles have different security requirements. So you will probably at some point in your career be asked to have a security clearance. So you need to be able to demonstrate that you've got a clear police record and that you haven't done anything to provide a criminal record, so that you can get your security clearance for your job. Keep in mind that some job roles don't require a high level of clearance, so you may be one of those people, but just bear in mind that a lot of the jobs should actually require some sort of clearance in the future. So if you're at school, the next question that was asked is what maths science subjects should I be studying? So I might take that one. If you're at school, I would recommend that you would always take the highest maths topic that your capability allows you to do, particularly if you're going into something like engineering, or as Sabruto mentioned, you might want to work in the signatures field or some higher level PhD. At the end of your career, you might want to look at doing the highest level maths, which would be your maths methods ATAR. Otherwise, you know, if you're looking at some of the trades, as I said, you probably just want to choose the highest maths that your capability allows you to do. As for science subjects, I'll hand over to Sabruto. He might have some ideas about what sort of science topics at school you might want to choose if you're going to go into something like sonar or electrical background.
Yes, so as we've seen, there's a lot of physics which goes on in the sonar. So when we are talking about science, we are mainly talking about physics. So it's better to have some background in physics, which will help you in the sonar. And not only in the sonar, there are a whole lot of sensors on board the ships. It will help in all those electronics also. So strongly recommend physics, definitely. And if possible, do some chemistry also, as you have seen that seawater is highly corrosive, and that is where your chemistry knowledge will help you. So that will help you in sorting out those corrosion on the metal surfaces which the ships are always exposed to.
So, Sabruto, I've got another question for you. If I have finished year 12 and I'm looking to do a pathway into something like Sonar, working with Sonar and shipbuilding industry, what sort of pathway would I be looking at? What sort of university courses or degrees would I have to do?
Okay, so if you want to be working as an engineer on Sonar, then you have to do electrical or electronics engineering in the university. And if you're looking for working as a technician, then you have to do Certificate 3 in electrotechnology. So that will give you the grounding for the entry level, which is working as an electronics engineer or technician.
Fantastic. Thanks, Sabruto. So I've got another question come through. There are many design roles in shipbuilding. So can I actually just go through a couple of what these design roles might be and how someone in our workforce register might be able to help with these roles? So if I'm looking at a design role for naval shipbuilding, any one of the engineering roles really take a bit of a design flavour. So from the very beginning, our naval architects are the ones that sit down and design the ships to the specifications required. So to do naval architecture, you've got to do a fairly specialised course, and you need to look at some of those courses which our consultant at the Workforce Register could help you with. Certainly some of the other engineering roles like mechanical or structural engineering do have a design element. And so if you are looking for some guidance around which one of those design roles you might want to do, please feel free to jump onto the register and one of our team can have a chat with you and take you through some more specifics about those roles and hopefully help you make a decision. Sabruto, is BAE Australia the only company working on sonar signal processing for Australia's future ships, or are there any other companies that you know of?
Okay, so when we talk about the ships, we have got two things. One is the ship structure as such, and the other is the number of sensors which are fitted on board the ships. So when we talk of sonar, sonar is one of the sensors fitted on board ship. So BAE, Naval Group, Austal, these are the shipbuilders who build the ship. And then we have other primes who like Raytheon or Lockheed Martin, Saab. They are the people mostly doing the electronics part. So they are into this sonar and signal processing.
Fantastic. Well, there's one other question here for you, Sabruto. This is a good one. Sonar is used to detect objects in other ships, but how do they stop other ships from detecting our submarines?
Okay, so that is an interesting one. So in the battlefield, it's a cat and mouse game. So both the parties have got sonar, both are trying to detect each other, and at the same time, both are trying to avoid each other. So that is where the signature engineering comes into play. So what happens is sonar is trying to, if it is underwater, is trying to listen to the sound made by the ship. That means the engines running in the ship, those sound will be emitted through the hull and they will be captured by the sonar. So if you want to avoid detection, you have to minimize that sound getting emitted outside the hull. So what you do is you use some padding to minimize the vibration, to reduce the sound. And the second part is the propeller, which is the most significant part of the submarines, and they make a lot of sounds. So if it is designed properly, you can minimize the sound coming out of the propellers. Other way of avoiding is to have something like radar or sonar absorbent material. So what they do is it's like a rubber coating all over the hull of the submarine, and that reduces a lot of sound being detected outside the submarine. So these are few techniques which a signature engineer tries to do that to minimize the sound, which will help in detection.
Fantastic. That was an interesting question. So we've just been asked what's our favourite part of working within the shipbuilding industry. So I'll go first and then I'll hand over to you, Sabruto. So my favourite part is really just being involved in something so technologically advanced and keeping on top of the cutting edge technologies. What would your favourite part about being in this industry?
Okay, so being ex-Navy, ship has always been close to my heart, and I was missing quite a bit after I left Navy. So for 10 years, I was teaching in electrical engineering, but my heart was always close to the ship. So when I got this opportunity to work with Naval Shipbuilding College, I again revived my interest and I went across, saw the ships, and it's really fantastic to see the range of sensors and the advancement in electronics. There's so many things happening in this area because my area is mostly towards the sensors. So I'm seeing that there's a rapid development of a lot of technology, very exciting, and I'm really exciting to see all this development.
Fantastic. Last question for the webinar today. So, Sabruto, would you recommend a job in naval shipbuilding for school students?
Definitely. That is the career I have taken, and I will recommend. There's a lot of challenges, lot of interesting technology happening in the naval shipbuilding. If you like science, if you like maths, go for it. There are plenty of opportunity there.
Fantastic. Thanks so much, Sabruto. It's been fascinating talk today and appreciate all your time and effort in talking through some sonar technologies.
Thank you.
Thanks, everyone.